Hello. Welcome back. If you went to go take the test yesterday and were wondering what's going on, it's because the test did get moved because we've got a little bit left to lecture on the electrons chapter. So we'll finish that up today, and then the test will be available for you on Thursday and Friday. Okay, if for some reason you can't get it done on Thursday, Friday, because like, let's say those happen to be the 2 days that you work like back-to-back shifts or something, please let me know and I can give you another option. So we left off and we were talking about our quantum numbers and how quantum numbers help us to describe our orbitals, and that there will be 3 numbers. So the first number being your n value. So we could do down here, I can give an example. So we could have an n value, and that could be, 1 and up, the lowest energy being 1. So let's say we go with 2. So that means we're at energy level 2, or we're at floor 2. Then we have an L number, and that tells us the shape. So that could be a sphere would be 0, 1 would be the dumbbells, the P's, 2 would be our D-shaped, and then 3 would be our 4 shape, which gets really, really funky. Just remember which ones you can use on which floors. So on floor 2 or energy 2, I have the option of having a sphere shape, or I have the option of having the P shape. So let's do 1 for P. And then we also have our magnetic quantum number, which is our ML. And that is going to be some value between L plus 1 and L minus 1, including 0 as an integer. So anything that would be validated here could be 0, could also be 2 for this one, 1 minus 1, or 2, 1 plus 1, okay? We can add one last number, which is this quantum spin number, which is the MS number. The only options available for this are going to be a plus 1/2 or a minus 1/2. Okay, and what that lets us know is, is your electron spinning up or spinning down? So if we were to, let's say we were going to do this first one here, if I was to extend it with my MS number, I would say I'd have a 2, 1, 0, and I could say that it's a plus 1/2 spin. Okay. Or it could be 2, 1, 0, and a minus 1/2. For each orbital description that you're going to have, you'll have either the plus 1 or the minus 1 option, because each one of those holds a total of 2 electrons. So this would be our N, this would be our L, this would be our MS, and then this would be, or I'm sorry, our ML. ML, and then this here is our MS number. Now, Pauli's exclusion principle, you can have up to 2 electrons in each orbital. So for this given orbital, the 2, 1, 0, we can have this electron or this electron filled in. They have to have opposite spins though. So we would never have a 2, 1, 0 plus 1 and a 2, 1, 0 plus 1. We need these electrons to be spinning up and down. And we'll talk a little bit more about that. So that's the additional number there. So quantum numbers, your quantum numbers, what we've been spending the last lecture or so on quantum numbers. They tell us, or they describe the individual orbitals or spaces where the electrons hang out, okay? Versus our electron configuration. Electron configuration describes the location of all electrons. Okay, so I think Brittany had brought this up last time and we had talked about the 1s2, the 2s2, and what was going on, how that's different. Well, we're going to get more into that, and that explains to us the layout of every single electron for a given atom. The quantum numbers just tell us the description of the orbital that we happen to be looking at. So when looking at our electron configuration, we're going to have a couple of different things. We're going to have a number similar to our N value, and this indicates the energy level. So indicates energy. And it corresponds to that first quantum number that we had looked at. So we've got N can equal 1, 2, 3, etc. We've also got a letter. This indicates the shape. Of the orbital. So what is our, what are our electrons sitting in? Are they sitting in a sphere shape, a P shape, so on and so on. So here we've got our S, P, D, and F. The important thing with this as well is it lets us know, the shape lets us know how many electrons we can have in each one of them. So remember, S can hold a total of 2 electrons. P can hold a total of 6, D can hold 10, and F can hold 14. Okay, so we max out at these numbers, 6, 10, and 14. The exponent will let us know how many electrons are in that given orbital, okay? So an example of this, just to tie all those things together, would be if we are looking at hydrogen. Hydrogen's electron configuration is 1s1. Hydrogen, if we look at our periodic chart, it sits right here. All right, there's 1 proton, and if it's in ground state, there's also 1 electron. So I'm going to fill my lowest energy shell first. The lowest energy shell is the 1s, 1 being the energy, s being the shape, and I have 1 electron sitting in it. So this would be my electron configuration for hydrogen. Helium, which is over here, also has electrons in the 1s, but helium has 2 protons, so it will also have 2 electrons. So instead of it having just 1 like hydrogen, we're actually going to fill it in with 2. And what happens is as you move down the periodic chart, you piggyback off of the electron configuration of the thing that came before it. So helium is just like hydrogen, but we add 1 electron. Okay, lithium, and we don't have them written on here, but lithium lives right there. Lithium is going to be like helium. So it has the 1s2, but then we have to add 1 electron, 2s, and we have 1 in there. And so on and so on. So this electron configuration will just sort of build on itself as we move through the periodic chart. Now, I want to fill in with this periodic chart, and you can write it on your own periodic chart as well. There's different sort of blocks so that you don't have to memorize the filling order. You can just read it off the periodic chart. So this over here is known as the S block. There's two columns, column 1 and column 2. So if you want on your periodic chart, put over column 1 and column 2, put the S block. And right here, we begin with the 1s. Okay. Over here, we have a set of 6 columns. This is known as the P block. Anytime you're in here, you're filling electrons in the P orbital. Okay, and we start with P2. Sorry, it's 2P. Clear that up so there's no confusion. 2P. Okay, so we've got the 1s over here. Here we always start P with 2P. So remember, we don't have a 1P. On the first floor here, there is no P. Right here is where our D starts. D doesn't start until the 3rd energy level or the 3rd floor. So our first D is going to be a 3D. Now that's going to feel a little strange because we have 4S here and we have 4P here, and the 3D sits in between those. So you can also think of D as always going to be n minus 1, or it's n minus its surrounding neighbors. Okay. F, which starts here, is going to begin with 4F. Okay. So the first F we bump into is 4F. F is going to be 2 less than the S and the P, and it's going to be 1 less than its D component. Now, where does this F fit in? Well, look at your periodic chart. What you'll see is that we go from barium, which is 56, to La, which is 57, only sitting here. And then all of a sudden it jumps to 72. Well, that's because cesium, number 58, is sitting right here. So we go 55, 56, 57, 58 jumps down here. And actually, this is one part I do like the slides, is it shows our expanded periodic chart. Okay, so right here. So this is what we would expect the periodic chart to look like if we had taken the lanthanides, which are these guys here, and we actually inserted them into their correct place. Okay, it would look something like this. But it's a little tricky around the barium, La, cesium, because we actually will fill one of our Ds before we fill the Fs. We'll fill the Fs and then we'll jump back to the Ds. And we'll look at that a little closer. So how to remember the numbering that you're going to fill? Well, this is column or row 1. So this is N or energy 1 or floor 1. So we fill the first floor. Then we go to fill the second floor, third floor. Then we go to the 4th floor. Then we jump back to the 3rd floor for our D. Then we go back to the 4th floor for our P. Okay, so if you want to, you can also write in here N equals 1, N equals 2, N equals 3, N equals 4, so on and so on, 6 and 7. Remember for D, N is, you take N minus 1, and for F, you take N minus 2, you're 2 steps down. So now if I want to read my electron configuration, like let's say we want to go to boron over here. Okay, so boron's right here. If I, I'll write it up here. So we're trying to go to boron. So its electron configuration, you always start at the very beginning. Just like when you're reading a book, you don't start with that random letter in the middle. You start with the very beginning or the start of the page. And we're going to, just like a book, read it from left to right, top to bottom. So the first thing I do is I fill in my 1s orbital. Now, do I fill it completely? Yes, because I have to move through these configurations until I reach boron. So 1s is completely filled. After I've filled the 1s, I go to the next line. Where am I at? I'm at the 2 and I bump into the S. So I fill my 2S next. Do I have to fill it completely? Yes. Boom, boom. I need to hit both of those. So I'm going to fill that in. After the 2S, where do I run into? I run into the 2P. 2P. And how many do I fill in there? I just fill 1 electron in. I don't fill the other 6 spaces. Does it sound weird, or is it just you? Let's see. Does anyone else, does it sound weird? It's breaking up. Okay. Let's see. My computer has been like, you know, when you can hear it spinning inside, it's running kind of rough today. I'm going to close out. I'm going to end the meeting and then I'll start it back up again. Okay, let's do that and see if we can get it to sound a little better. We'll stop share, end the meeting, come back in